Okay, the next topic is to find out the distance between the point and the plane. If there's a point above the plane in 2 dimension, then there's a formula to estimate the distance between the plane and point. So we have to first set up the normal vector on the plane, and the reference point on the plane to arbitrary direction could be defined by the vector. So the way to define that distance from that point to the reference point could be given by the dot product and the normal vector. Let me show you how to define that distance between the point and the two-dimensional plane. So let's assume there's a two-dimensional surface, and basically we set up the direction with the normal vector on the surface, so that there's a point on the surface of the plane that is point P, which is the reference point, and that the point above the surface is labeled with a Q. So what we need to do is find out the distance between Q and this surface A, the plane. This is normal vector, and now the directional vector from reference point P to the point of interest, the Q, could be defined by PQ, that is vector P and Q. And the best way to find the distance between the Q and the plane A is to project the Q onto the plane A and the normal vector N. So let's split that vector PQ onto the plane A and the normal vector N. So if you project that, it should be like this. So that is perpendicular. The vertical line out of this Q onto the plane A is perpendicular to the plane A. Also, you extend the line horizontally onto the normal vector N. So the distance D, now this projected vector onto the N from the vector PQ could be defined by project N of point PQ. So distance D from Q to onto the point A, B, is the magnitude, amplitude or magnitude of this projected vector PQ onto normal vector. So that could be also expressed with the magnitude PQ plus dot product normal vector N divided by the magnitude of normal vector. That is definition of the distance D of point of interest to the plane of area A. So to find the point in the plane given by the AX plus BY plus CG plus D equals 0, then from the equation AX plus D equals 0. So you can conclude that the point minus D over A 0, 0 lies in the plane. So let me change the color. So to find a point in the plane given by AX plus BY plus CG plus D equals 0, that is plane A. Here's A should not be equal 0, and the Y, then you should just let Y equal 0 and Z equal 0. Then from the equation, this equation change to the AX plus B equals 0. Then you can conclude that the point, so that's X should be then minus D over A. And the point on the plane should be the X minus D over A, 0 and 0. That point should be on the plane A. So that could be the point can be used as reference to justify the distance too. So let me just go with this definition with the example problem. So let's find the distance between Q1, 5 minus 4, and plane A, 3x minus b, plane y plus 2z equal 6. Here, normal vector, as you know, this is A, this is minus 1 is B, and C equals 2, and D is minus 2. From that, normal vector, based on its definition, 3 minus 1, 2, but this is A, B, C. So now let y equals 0 and z equals 0. Then that should be 3x equals 6, so x is 2. So that point on that plane A should be 2, 0, 0. Now PQ from that should be 1 minus 2, 5 minus 0, and minus 4 minus 0. So that is minus 1, minus 5, minus 4. So use this point, you can estimate the distance between the point and the plane. Based on the definition, it's PQ, absolute value of dot product between PQ and normal vector n, divided by magnitude of normal vector. So that should be minus 1, 5. That should be 5 actually. 5 minus 4. Dot product 3 minus 1, 2. By normal vector is the magnitude of normal vector is 3 squared plus minus 1 squared plus 2 squared. So that is square root of 14. So from that should be minus absolute value of minus 5 minus 8 divided by square root of 14. So that is 16 over square root of 14. That is distance between this Q and the plane A.